Hi all, this is Yunus. Welcome to my channel. In this video, I want to discuss about the basic principles behind NoSQL databases. I'll talk about some of the disadvantages of RDBMS databases or SQL databases and the need for something better and why the market felt the need for something better and how the basic principles of NoSQL is actually solving that problem. And towards the end, I will use Amazon DynamoDB to explain about how the data is stored, how they are accessed, how the scaling up of read and write capacity is done, etc. Okay, let's start. In this video, I want to discuss about the differences between an RDBMS database and a NoSQL database. So when you are using relational databases, we know that a relational database is a collection of related tables. If you want to get all the details about a particular entity, you need to parse through multiple related tables. For example, this is a healthcare database where I have all the details about multiple patients, their visits to various hospitals, and the doctors they have consulted, the hospitals they have gone, the treatments they have received, etc. So here the first table is the patients table where, for example, I want to get all the details about one Mr. Albi. So I'll go to this table, or my application will go to this table, get the details about this Albi, especially the patient ID, and then the application will go to the visits table and get all the details about the visits for this particular patient. And then application will go to the next table, which is the treatments table, to get all the details about the treatments which this person has received. And then to get the details of the doctors who have treated this person, you may need to go to the doctors table, and then you have to visit the hospitals tables to get the details about the hospitals where this person has visited. So just imagine, here I have included only five entries in each of these tables, right? But in real life, there may be 1 million entries or more in each of these tables. So to search through each of these tables to find that one entry among this 1 million, and that too you have to go through multiple tables. This may take hours basically. So that is one of the biggest disadvantage of a relational database, that retrieving data is cumbersome. It may take minutes or hours. And the problem is that in today's web scale companies, so what are web scale companies? The companies which provide their services based on the web, such as Facebook, Amazon, Google, Netflix, etc. We know that Amazon has 310 million customers, Netflix has some 240 million customers. So they have hundreds of millions of consumers. And each user or consumer has her individual page. For example, when I log into my Netflix page, I get all my bookmarks, which all movies I have watched, till like 30th minute, 35th minute, etc. Similarly, when I log into Amazon, I get my page with my recommendations, my shopping cart, my order list, etc. So each individual user has her own individual page. When a user logs in, within seconds, all his or her data need to be retrieved. Okay, so if these web scale companies are using relational databases, you can just imagine how messy things will be. 310 million customers, and you have a number of relational database tables, and it will take hours and hours to retrieve the data for one single consumer. Retrieval times need to remain unchanged even when consumers increase manifold. That is also another requirement for web scale companies. So to improve the speed of retrieval, the first thing they did, or the first change in paradigm, was that they decided to actually store all the data which is being retrieved together need to be stored together. If my application need to get all the details about the patient Albi, all the details which are relevant for this particular patient should be stored together. It should not be stored in 5 different tables, but in one single storage location. So that was the first paradigm change brought in by what we now know as NoSQL database. The basic principle is that all the data which has to be read together need to be stored together. So that is the first principle. So you will not have multiple tables. Unlike earlier where you have 5 tables, now you will have only one storage area where you will have all the data put together. The other issue with respect to the web scale companies is that the personalized data for one consumer is different from another. For example, the list of bookmarks in my Netflix page will be different from yours, or the list of items in my Amazon shopping cart will be different from yours. My product recommendations will be separate from yours. My orders I have placed in last 1 year, that list will be completely different from yours. The length of items, maybe the attributes about each of the product will be different. So basically the data for me will have a different length than the data for another consumer. You may have certain fields which I may not have those fields, and you have to keep in mind that there are hundreds of millions of such consumers. So this kind of variation in actual data calls for flexible data schema. You can't insist on having a fixed schema. It will never work for modern day web scale companies. So if you go back to that data again, you can see that for this particular patient, Albi address is given, then phone number is given. Here phone number is there, but email is also there. Here email is missing. And this person has made 3 visits, whereas Albi has made only 2 visits. So there will be many other differences. Here I am showing only a small simple example. So that is the other principle of NoSQL tables. What is that? So you have to follow a flexible schema. So we saw 2 properties of NoSQL tables, or 2 important principles behind NoSQL tables. And how the data is stored in NoSQL, if you look at a SQL table, you can see that, or if the same data is stored, the patient data is stored in a SQL table, it will look something like this. There will be some null values, you can see that here, but it is possible to force fit the data into a normal RDBMS table. But this is not how the data is stored in NoSQL databases. It is stored as JSON documents. So you can see all the data about Alvin is in this storage area or put together. All the data about Bill is here, and all the data about Cindy is here. So basically all the data about a patient is stored together as JSON documents. But when you are working with these tables, those table user interfaces can actually show this data to you in the table format. That is different, but in the backend, this is how the data is stored. And please note one thing, that in case of SQL RDBMS table, you have a column title, and under patient you can write all the patient names. But here you can see that with every record or every item you have to write the word patient, then patient name, ID, and then the ID. Here also same. So you are actually repeating, if there are 1 million entries, you are repeating this name of the field 1 million times. And the name of the field is known as the key, and the actual value is called value. So that's why it is called key value data store. So you can see that storage efficiency wise, maybe the RDBMS table is more efficient because you are not repeating this word patient 1 million times, right? But it is proven that the performance efficiency brought in by the NoSQL table is way above the cost of additional storage which it incurs. Now, how this data is stored, we need to go little further deep into that. For that, I will explain it based on how Amazon DynamoDB works. So when you start a new table in DynamoDB, it will ask you to enter a partition key. That is very important because the data is actually stored based on your partition key. If you have separate partition keys, the data belonging to each partition key will be stored separately. So here, this is an imaginary table where I have listed all the countries in the world, and the partition key is the continent name, which is Europe, Asia, Africa, etc. And the sort key is the country name. Sort key is optional, it is not mandatory. If you want to list all the countries across the world based on the GDP, you can actually make GDP as the sort key. I will come to that. So here the partition key is continent and the sort key is the country. And how the data is stored? Data is stored separately for each partition. Partition Europe will have a separate area and partition Asia will have a separate area. And the maximum size of this partition is 10 GB. So based on the partition key, you will have separate storage areas, and the maximum size of that storage is 10 GB. And within that storage area, you can see that based on the sort key is country name, so it is actually sorted according to the country names. Instead of this, if you want to say, for example, if your application need to list all the countries based on their population or based on their GDP, basically what you can do is you can make the population as the sort key. So according to the population, it will be sorted and written inside the partition. And for each of these partition, there is an access mechanism, okay, and the maximum speed, access speed or retrieval speed provided is 3000 RCU read capacity unit and 1000 write capacity unit. So about this RCU and WCU, I have done another video. I'll give the link. You can go and check what RCU and WCU means, but just understand that the reading speed or writing speed of a DynamoDB table is defined in terms of RCU and WCU. So for a 10 GB partition, the maximum RCU and WCU allowed is this much, 3000 RCU and 1000 WCU. So there can be cases where your application requires more than 3000 RCU or more than 1000 WCU. In such cases, how do DynamoDB provide that increase in speed? That's what we are going to see next. So we already discussed that the maximum size of the partition is 10 GB. Okay, so this whatever partition you see here, maximum capacity is 10 GB. So there are two scenarios when you need to add more partitions. The first one is your data grows beyond 10 GB limit. So you have to create a new partition. AWS will automatically handle that. And the second scenario, which is more important, is when you need more write capacity or read capacity, what AWS does is AWS actually splits the partition when you need to improve write capacity or read capacity. So it will look like the same partition will be split into two, and it will look something like this. Say a few countries, half of the countries will be here and half of the countries will be listed here. And AWS does it automatically, and it has its own internal mechanism to identify that if you have to list all the countries in Europe, it need to go through both the partitions, not just one single partition. So the advantage here is that you have maximum 3000 RCU for each partition. So automatically it has increased the capacity to 6000 RCUs here. And this is done automatically by AWS behind the scenes. So it is something like, let me give a non-technical example. So assume that in your city, there is a city parking complex, and this is the highway. The cars come from the highway and they come to the parking area and parks there. But of late, you have noticed that the traffic on this access road is very heavy, because of which the traffic block is spilling over to the highway. So how can you manage that situation? The parking area inside the complex, there is sufficient parking area, but the problem you are facing is the access road is actually congested. So even if you add one more access road, the facilities inside the parking complex may not be sufficient enough to handle that kind of traffic. So adding another access road, it may not be possible because of the processes, because of the traffic conditions within the parking complex, plus the fact that maybe there is no space for another access road. So what you can do is you can actually create another parking area, of course, and there is no rocket science here. You can create another parking area wherever there is space, and maybe 50% of the traffic will, 50% of the cars will go to the second parking complex and 50% will remain here. So the access speed issue will be sorted out. So this is the same approach which is taken by DynamoDB. When there is more read capacity unit requirements, it just increases the number of partitions. And this design actually ensures that the retrieval speed remains constant with customer growth, because these companies today, if they have 310 million customers, maybe after 6 months they may have 350 million customers. So if they follow this design, they can actually provide the same read-write performance even when the number of customers increases manifold, because they are increasing the number of partitions when they need more read-write speed. So when an Amazon customer logs in, she gets her personalized page in seconds, and that magic is possible only with NoSQL. If you are continuing with the RDBMS database, you will not be able to achieve that. Okay, that's it about this video. I hope you enjoyed this one. I'll come back with more useful videos. Please consider subscribing to my channel. Thank you. Bye.